Okay, so in this example, we're going to be talking about how to find the inverse of a function. Now, this is pretty straightforward. All the inverse means is that your x and y values are going to flip. So when you have an original function, we'll just say f of x, and you find the inverse of that function, f inverse of x, the x values and the y values are going to end up flipping. And I have a definition right here, so you can go ahead and read it. It says the inverse of a polynomial will have x and y values that are flipped. For example, x values become y values and y values become x values. Now, this is pretty important. If you were to graph these functions, which we're not going to do in this video, but if you were to graph the original function and then the inverse function, you would see that it is going to be reflected across the line y equals x. So you can always do a quick confirmation in your calculator to make sure that you did in fact get the correct inverse function. They should be reflected across that line y equals x. So it's a nice little quick visual check you can do to make sure that you did the problem correctly. But just looking at the example I gave you down here, you have some function f of x right here, and then you have another function f inverse of x, okay? And so that exponent that is -1, that simply just means f inverse of x. So you wouldn't read that as f to the -1 of x. That simply means f inverse of x, okay? And so if you look at your table of values, you can see on my original function, f of x, my x values are 1, 3, 5, and 7, and then my y values are 2, 4, 6, and 8. Well, if you look at the inverse function, what happens? Your x and y values flip. So now my x values are going to be 2, 4, 6, and 8, and then my y values are now going to be 1, 3, 5, and 7, okay? So let's go to our first example and talk about how we're going to find the inverse of a function. So here's our first example. You can see that we have a linear function here. They also give us the domain and range. So we can see that on this linear function, the domain and range is going to be all real numbers on both of them. Now remember, domain corresponds with your x values and range corresponds with your y values, okay? So that's important to remember in this video because we're going to want to list out the new domain and range of the inverse function when we're done, okay? So let's talk about how we're going to get the inverse function of our original function here, f of x. Well, our first step is to take it out of function notation. We know that f of x is really just y. So I'm going to go ahead and rewrite this as y equal to 3x plus 2. All right, so your first step, take it out of function notation. Now your second step, you want to flip the x and the y variable. So wherever you see a y, you're going to switch it with x, and wherever you see an x, you're going to switch it with y. So for example, I'm going to go ahead and rewrite it as x is equal to 3y plus 2, just like that, okay? And now once you make the switch, you want to solve for y. So my goal here is to solve for y. In order to do that, I have to subtract 2 and then divide by 3. So for example, I'll have x minus 2 equal to 3y. And then to get rid of that coefficient of 3, we have to divide both sides by 3. So dividing both sides by 3, okay, this will cancel. I get y is equal to x minus 2 all over 3, okay? Now we want to put it back in function notation. I don't want to leave it as y equals. So putting it back in function notation, I'm going to say f inverse. So f inverse of x is equal to x minus 2 all over 3. Okay, and that's done. So I'm going to go ahead and box that in. There is the inverse function, okay? And now we want to state the domain and range of our new inverse function. So if you look over here, our domain is being represented by x values. Our range is being represented by y values. We know that when we take the inverse, the x and y values flip. So it's really simple. All you have to do is look at your original domain and your original range, and they simply just flip. So my domain now becomes my range, and my range now becomes my domain. Now this one's easy because for both the domain and the range of the original, it was all real numbers. So for my inverse function, I'm just going to keep it as all real numbers on both of them, okay? And that's it. So you can see my domain and range, all real numbers. All right, let's try another example. So here's my next example. Our first step, take it out of function notation. So I'm going to say y is equal to 1 over x plus 1, okay? Your next step, you want to replace the y in the x. So I'm going to say here, x is equal to 1 over y plus 1. And now I solve for y. Now, to make this a little bit easier, I would go ahead and put these two terms in your denominator in parentheses, okay? So I'm going to get rid of that entire denominator. In order to do that, I'm going to multiply both sides by y plus 1, okay? When I do it to the right-hand side, that will cancel out here. But I also have to do it to the left-hand side. So I get y plus 1 there. And now rewriting it, I get y plus 1 times x equal to 1. So from here, we have to divide both sides by x. That will cancel the x's out on the left-hand side right here. And then divide this side by x. There we go. So now we have 1 over x. And now I have y plus 1 equal to 1 over x. I don't need the parentheses anymore. I'm good. I can drop them. All I have to do is take this positive 1 and move it over to the right-hand side. I will get y is equal to 1 over x minus 1. Okay? So from here, we want to go ahead and put it back in function notation. So I'm going to say here, f inverse of x is equal to 1 over x minus 1. Okay? And so there it is, completely done. All right? Now, what's going to be the domain and range of this new inverse function? Well, look at your original. The original domain was all real numbers except x cannot be equal to negative 1. Okay? And then my range was all real numbers except y cannot be equal to 0. So my domain is going to be what here? Well, I'm going to look at the range of the original. I know that it's all real numbers except y cannot be equal to 0. That means my domain of the inverse is also going to be all real numbers, but instead of y here, you're going to put x. X cannot be equal to 0. Again, we're putting x there because we're talking about the domain, right? X corresponds with the domain. And now doing my range, all I have to do is look at the domain of the original. It was all real numbers, right? Except what? X cannot be equal to negative 1. Since I'm talking about the range here, I'm going to say y cannot be equal to negative 1. All right, and there it is. All right, let's try 2 more examples. So here's my next example. We have a cubic. Okay, so let's go ahead and take it out of function notation. I'm going to say y is equal to x cubed plus 3. And now we make the switch. So this becomes x is equal to y cubed plus 3. We have to now minus 3, so I get x minus 3 equal to y cubed. And now we have an exponent of 3, right? We have y cubed. To get rid of that, we have to take the cubed root on both sides, all right? So we're going to go ahead and take the cubed root on both sides here, and we get the cubed root of x minus 3 equal to y, just like that, okay? So that's how we can deal with that exponent, right? Very similar to how you would get rid of a power of 2. You would take the square root. Well, I have a power of 3 here, so I need to take the cubed root, all right? So writing it in function notation, I have f inverse of x is going to be equal to the cubed root of x minus 3, okay? And that's done, all right? Now this one's easy. When we list out the domain and range, if you look at the original, both the domain and the range for the original was all real numbers. So that means my domain and range for my inverse is also going to be all real numbers. So I'm going to say here domain, all real numbers, and then my range, same thing, all real numbers. Okay? All right, let's try one more example. So here's our last example. First step, take it out of function notation. And again, this is going to be a linear function. We can see that here. This is going to be a line, right? So I'm going to say y is equal to 2 times x plus 3 and then plus 5. Okay, now we make the switch. So x is equal to 2, and then we have y plus 3 and then plus 5. Okay, and now we solve for y. So our first step, let's get rid of this positive 5. We have to move it over. So we're going to subtract 5. I'm going to say x minus 5 equal to 2 times y plus 3, okay? From here, let's get rid of 2. We know that it's multiplication, so to get rid of it, we're going to divide. So I'm going to divide both sides by 2, Okay. So now I have x minus 5 all over 2 equal to, we can go ahead and drop the parentheses now. We don't need them anymore. Y plus 3. Okay. Now we have that positive 3. Our last step, we have to move it over. So we're going to subtract 3. And I'm going to do this all in one go. I'm going to go ahead and put it in function notation. So I'm going to say here, f inverse of x is going to be equal to x minus 5 all over 2. And then again, we said we have to subtract that 3, right? So minus 3, just like that. Okay. So there's the inverse function. And now again, this one's very simple because our domain and range of the original was all real numbers. So that means the domain and the range of this inverse function is also going to be all real numbers. Okay. So domain, all real numbers, and then our range, same thing, all real numbers. Okay. And that's it. So that is how you find the inverse of a function. It's pretty straightforward. Just make sure you take it out of function notation first and then replace the x and the y variables by switching them, okay? Also, just keep in mind, if you were to graph the original function and the inverse function that you obtain, they should be reflected across the line y equals x. So that's it. I hope that you found the video helpful. I hope that you gained something from the video. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe to the channel. That way you get more math videos in the future, and I'll see you in the next one.